Hello, my name's James Taylor and welcome to Invalid Entry, and today we are going to be looking at some architecture decisions and some thinking, some thought processes around architecture. So I've talked about this previously a little bit, but I want to talk about some of the things that are considered when I've been doing architecture. I was a system architect for a very long time. I'm just going to jump into the situation. So the scenario we have here is that we actually have a 3D printer. I have one of these Delta 3D printers, so it looks a bit like this. And plugged into that, it has a computer because I use Octoprint. Not important to this discussion, but I use things Octoprint. I also have a Discord bot over here, so I have a little robot which is going to talk to people. Hello. And this little robot here is basically the question is, I want when something starts to print or if the print fails, and at certain points the print progress points to the print, I want this little robot to say print started. I've also got a webcam attached to this Octoprint. It's actually attached to an MP streamer, so that this actually can put a picture of what I'm printing into one of the Discord channels, and people can feel informed and sort of know what's going on. It also means when I'm out and about, I can send a message to the robot and say, hey, what's the status of my print, without actually exposing Octoprint onto the internet, which is something I don't really want to do. So in this setup where I've got a trigger or an event happening and I want a message to go out, there's some questions that we have to answer, and there's some options that we have when we're thinking about the architecture. And first of all, there's no real wrong answer in this. There are a lot of answers which may be wrong for you or for a particular situation, but generally speaking, there are no wrong answers at all. I mean, that said, there's a lot of wrong answers, but we're going to cover the main ones. The first one is that I can put a module, or I'm going to put some code here, and I'm going to put some code here. That's taken for granted. So we should look at what these systems actually do. So Octoprint is controlling the print jobs. It's obviously the trigger of the event, say a print has happened or a print has progressed. It has in it a whole bunch of systems. It's got some modules here. It's got a modular, so I can write a plugin for this. I actually am going to use, just so you know, I'm going to use the webhook plugin. I'm going to talk about that again in another video. I'm going to use a webhook plugin, a little bit of code here, which is going to just interpret those events and filter those out. On the Discord bot side, the purpose of this bot is to interact with Discord. It uses webhooks, it uses an async loop. So this here is a nice system. It's well defined what's going on here. And then we've got the communication between the two, and this is where you begin to bring in some of the system architecture. So software architecture is interested in how this bit of software works, and the software architecture is interested in how this bit works. The system architecture is how these two discrete components communicate with each other or work together to produce something bigger than their individual parts. So the first thing we can imagine doing is just sending a message directly, like make this a web server interface over here, and send a message via a webhook straight into the bot. That's option number one. Option number two is using some kind of queue, and option three is using some kind of pub subscribe thing. Now, last episode I did talk a lot about queues when I actually meant pub subscribe, because I'm using a pub subscribe system as a micro queuing system. Now, which of those three things to use kind of depends on the environment you're in. So there's some benefits and some disadvantages of all those three systems. In the webhook system, when I'm firing a message across via webhook, a web request, it means I know over here whether that's been received or not. But it also means I have to handle that issue. So if I send a message and the bot isn't running, then it won't get through. So I have to handle that error, either send it again later or whatever. Whereas with the queuing system or public subscribe method, it becomes decoupled, which means I can send these messages in. This can either be there or it picks them up later or whatever. It doesn't error on the left-hand side. The left-hand side can focus on doing what it's supposed to do, which is controlling the print job. However, before you start saying, oh, well, we'll go to that model, is if you are only using webhooks between systems and you don't yet have any experience in managing queues or running SQS or Rabbit or Redis, then that might be the right answer. And this is where your sort of enterprise engineering hat comes on, and saying, what skills do you have in-house? What's the existing systems are like? Rather than just starting adding more and more technology to all your systems and having some queues in Rabbit and some queues in SQS because Rabbit was better in some circumstances. Sometimes it's better to use a slightly worse architecture because you have the skills in-house, you have the knowledge of how to manage those systems, how to support them, back them up, keep them processing. Sometimes it can feel like you're hitting all your problems with the same hammer. It's like, this is the problem I have with Nginx. I use Nginx a lot in my solution because I really understand Nginx and know how it works. So you come along to a system and goes, I'll use Nginx as a solution here. And that's fine, because it means that if you have people who really understand Nginx, you can then continue to use that as all kinds of different proxies, all kinds of different modes, as barriers, as gateways, as all kinds of systems, access control systems, the works. But sometimes you are using that sledgehammer to crack a nut. When you have a hammer, everything in the world looks like a nail. So yeah, because you put Nginx in between these two systems, they may be on different networks. That's something to consider, is actually what is the separation of these two systems. Is one running on-prem? Obviously this Octoprint's running on-prem. Is this running in the cloud? Luckily for me, they're on Pis. They're actually they're on the same Pi sometimes on the different Pis, but that's a bit of an interesting situation. So how you communicate is the first question we're going to answer. We're actually going to use a pub/sub method. We're actually going to use Redis in the middle here. So this is going to send a message to the middle, and then this is going to be watching that. So I'm going to draw an eye like this, watching that queue or pub/sub method, and it's going to be triggered when an event happens. So now on to the second question of what is that message? And obviously it's a printer started. That's the message. That's the information in the message. That's the knowledge that's in the message. But it's not necessarily the data that's in the message. And what I mean by that is, which is the system which is actually going to generate the human readable text going to the Discord channel? And you've kind of got two options here. The first option here is this queue here. So option one is this queue here is send a message. So at this point, the left-hand system knows where it's going to. So you want to say Discord channel, the text a print has started, and so on. Make all that text formatting happen, put it onto the thing. This pulls it up, shoves it in the queue, which makes this dumb. It doesn't necessarily understand what the message is. It just knows, I was supposed to have sent a message, and it delivers. So it makes the function, the purpose of this thing on the right, just to deliver messages to the correct place. And it makes the function, this thing on the left, it begins bringing business logic into this, saying, I want it worded like this, I want it to be in English, I want it to be in French. All that happens over here on the left. So the other thing you can think about doing is actually not having that. Have this queue not be Discord message, but actually be print started. At that point, we're going to send a message to queue, which is data. The information of the message is a printer started. It has a type of start, it may have a type of finished, it may have a type of progress 10%. At this point, this is going to be watching that queue and say, okay, because a print started, I should apply a template, I should apply a message format on that. Which means this system on the left becomes focused only on printing and publishing events indicating a print has started, whereas the system on the right is now picking that event up and interpreting the knowledge about what to do with it. It shifts the business logic to the right. It's a subtle difference. The difference in this is subtle. It means that when you start thinking about this is, on the one system, if you start expanding this out to multiple systems, so I have printing, I might have my security system, and so on. On the top system, I have a message Discord queue or pub subsystem. I have Discord bot. Okay. In this system, all these systems will write that queue, and then the Discord bot will pull out. So you've got a many-to-one situation going on. In the other system, what you've got is a print, security, and so on, writing to their own queues here. Print event, security event, and then you've got the Discord bot pulling from those queues what it's interested in. This architecture becomes interesting because I can then have another bot here or another system here, PagerDuty or some system which says I'm only interested in security events. I'm not interested in printing. Or then you may say I'm only interested in print finish. So you start going down, do I want one queue here or do I want 5 pub sub things here? One for print start, one for print finish, one for print status. The other advantage up here though is that I can then add in new systems really rapidly. So I can make another system here called, I don't know, temperature, weather. And when the weather also publishes, I don't have to do any work on the right hand side because it's already picking those messages out. So advantages to both architectures as you go forwards. There is, of course, a third architecture, and I'm going to need a little bit of paper. I did know this was a 3-bit of paper job. The other architecture is sort of an amalgamation of both, where in your queue system you might have a send message which is listening on just one system. The robot is just listening there. Yay! You may have on the right hand side Octoprint, security, and weather, and they will have their own queues. There is nothing stopping one of these talking straight to that queue if you want to, if it makes it simpler to do it. But what you're able to do now is write a microservice here, which is the message writer, which is listening to these queues and then passing into that queue. So the weather might put straight into the queue because it might be more tightly coupled. But this messaging service might say, yes, I'm actually going to intercept those messages, those events, and put them onto the next queue. This architecture is good if you're able to write microservices, if you're able to write and run small containers, ideally, but small programs which aren't going to crash, aren't going to fail, don't require a lot of help restarting. So if you've got Windows services or Docker daemons or daemons, maybe, you don't want to have a lot of console applications running. These could be lambdas or something similar as well. And that's the way you're able to then, again, throughput of messages or those kind of situations all matter. But this kind of architecture allows you then to decouple really from what is the purpose of this system, what is the purpose of this system, and what is the purpose of this system. And they all have very distinct purposes. This is the better architecture. This allows you to do a many-to-many approach. It allows you to bring other systems, which are taking just from here and passing into PagerDuty, for example. I can take from my home automation system. But the problem with this system is it's more work. There are more interactions to do. There are more things to document. And if you're in a commercial environment, you may have more security things to work out. You may have to go through a lot more detail on this. Which brings us back to maybe sometimes the one of these first architectures of a very simple one-to-one coupling becomes more advantageous. Or even the webhook where it goes straight through becomes advantageous. So architecture is not so much necessarily about designing systems that work, but rather designing systems which work in the context of the organization you're in. And that's a really big thing to think about if you're thinking about becoming an architect, especially a systems architect or an enterprise architect, is looking at what your organization is, who have you got working with you, who are the kind of people that you've got, what skills they have, what systems are already in place, and therefore can you reuse or piggyback on. Anything which reduces effort, anything which can already be supported that you're just adding a little bit on, is always better than saying, no, we're going to do something completely different. So here, for example, in my system, I'm not going to jump to using SQS. I know SQS really well. But at home, I don't have an Amazon. I do have an Amazon account. I don't want to use SQS. I don't want to send all my traffic to the cloud and put it back down again when I can use something locally. So I'm going to use a Redis thing. So it's worth thinking about your architecture. It's first thinking about, I always like diagramming out, saying what's going to what. It's always worth thinking about what your future is as well. Whilst I'm only dealing with a printer right now, going to Discord, I have got security going on, and I will have weather going on as well. I will have a weather bot going on saying, oh, this is the temperature. It's also thinking about the reverse as well. When I get messages coming into Discord, may they want to go to the weather. So I might have a system where I have a different one where the Discord bot will fire into different queues, and what's the coupling there? At that point, I may have something like an email version. Who uses email anymore? But email it, and it will go in and fire a message in, and then get a reply later. So these are really nice ways of decoupling your systems. And that's just sort of one intro into system architecture, because system architecture is all about systems talking to systems, how they talk to each other. Before we start getting onto the detail, what's the JSON message, what's the content of the message, what's the future compatibility and backward compatibility we have to deal with. This is just starting to think about that high-level picture about how these things might interact. But I've got to go away and build this now. So yeah, this is going to be a bit of fun. I did start talking about Redis. I started building Redis. I started building in my last episode a Redis system on my Discord bot. I do have a system already. I went away and built it. I recorded it, and I threw that video away because it wasn't very good. I found some security issues with it, so I'm going to re-record that video and get it up in about a week or so. But thank you very much. If you enjoyed these, if you want to see more of these architecture stuff, please leave me a comment below. If you have particular things that you think architects should be doing, or you bugbears that you hate about architects, because sometimes people are the architects are deciding it should be worked this way. It'd be really interesting to know, because sometimes there are reasons behind what they're trying to do, and sometimes architects aren't very good at explaining the reasons. They've come along and said, this is the architecture that I've decided on, without really explaining how they got to that thought process, or what other ideas that they had and discarded on that way. There can be an awful lot of time going to architecture. Sometimes I take a lot of clients, go away for a day or two and come back, so I kind of thought about it, it's percolating through the old grey matter. But yeah, that's architecture in a very brief nutshell of a very small system, and sort of the thought process that I've gone through, and where I've got to on my design. Thank you very much, and I will see you all in the next episode.